Okay, the last section we're going to look at is 8.4, and it's on two things. DeMoivre's theorem, which is how you can take a complex number and raise it to a power, and nth roots, which is how you can undo raising something to a power. Okay.
Is that French?
DeMoivre?
Yeah.
I think so. I'm guessing he was.
Yeah.
So let's pretend that you had a number in trig form. Okay, they would give you r, they'll give you theta. And I want to take that number that's in trig form and raise it to the second power. Now, the goal here is to do this, you notice a pattern, and then I'm going to ask you what the third power would be, based on looking at the answer that we get right here. So we're not really doing a proof of DeMoivre's theorem. We're more like doing something out the long way, noticing a pattern, and that pattern is DeMoivre's theorem. Okay. So, square basically means you'd have to take that and multiply it by itself. It's kind of long to write, but that's what it would mean to square it. Now, you've got four terms you're multiplying together. 1, 2, 3, 4. A couple of those need to be FOILed. But the r and the r, you can just multiply those two together right now. What's r times r? R squared. Now, pretend like the other r is now in front. We're foiling the parentheses. Okay, this r is gone. What's cosine times cosine?
Cosine squared.
Yep, cosine squared. And then cosine times I sine is just cosine times I sine. But then this is also cosine times I sine. So how many of the cosine I sines do you have? 2. So what we're going to do is write it like this. It's 2 of the cosine I sines. You can write that all in any order you want. It's like saying 2 times 3 times 4 times 5, or 2 times 4 times 5 times 3. So we're going to write it like this. I, 2, sine, cosine. That's 2 of the cosine I sines. That's fine. And the last part. What's I sine times I sine?
Or no, I
Negative 1 sine squared, because I times I gives you a negative 1. So there's that. Sine times sine is sine squared. So all I'm going to do at this step is I want to take term 3 and put it right after cosine squared. And what this is going to do is give us an identity from section 7.5. Okay, so we're going to have to remember what that one is. So you've got this, cosine squared minus sine squared. Just rearranging. Plus the rest of it. Sine theta, cosine theta.
Wait a second. You say cosine squared, sine squared, something special?
It is. And we have to figure out what it is. It's not like sine squared plus cosine squared. That's 1. Cosine squared minus sine squared is something else that's special. And we get it in section 7.5. Anyone have their, if you look at your notes from 7.5, under double angle formulas, cosine squared minus sine squared turns into something. It was something we had 3 versions of. It'll be under your double angle formulas. Which will be right before your half angle. So. Did you find it? What is cosine squared minus sine squared?
Cosine 2 theta.
Yes. That's a special identity from 7.5. And so is this last part. 2 sine cosine. That is something special too.
Isn't that like equal 1?
Nope.
No.
What's 2 sine cosine?
Does it equal
It's what?
Sine 2 theta.
Sine 2 theta. So those are the identities. So that's the final answer.
Oh.
So look at what you got. I'll make it a little smaller here. Look at what you started with. And you squared it. So what ended up happening to get from this box to that box?
R squared.
You what?
You double both of the arguments.
So you multiplied the argument by the power. And what about the radius?
Squared.
You raised it to the power. So if we did the same problem with z cubed, what do you think the answer would be?
R cubed plus cosine 3 theta plus I sine 3 theta.
Yep. And what we've just come up with is a very, very fast way to raise a number to a power without having to do all this foiling. I mean, think of how long this foiling took. It was only squaring. Imagine to the 20th power. Now you're going to FOIL 20 times. All kinds of stuff. So now with this theorem, you don't have to do it. Okay? But what kind of format is this when you write r cosine theta plus I sine theta? What do we call that?
Trig.
It's the trig form. So you can use DeMoivre's theorem, but you have to be in trig form. Doesn't work in standard form. So if I give you a number in trig form, or if it's not in trig form, you can get it in trig form. That's what you did last night. If you want to raise that to the nth power, two things. Raise the radius to the power, multiply the angle by the power. And that's DeMoivre's theorem. So that's the easy part, raising to a power. Now we're going to do a couple examples, and it's pretty easy. The harder part is reversing it and taking a root. Luckily, taking a root involves a little bit of this, though. So kind of builds on what we're doing right now. Good. Everybody have DeMoivre's theorem? Let's try an example. Now, they just want me to cube that. Honestly, I could probably cube that just as fast using DeMoivre's theorem or not using it. Because it's not in trig form. So it's going to take me maybe 20 seconds or so to find the radius and the angle. And then I have to cube it. Or, if they didn't say use DeMoivre's theorem, I would write that out 3 times, FOIL the first 2, and then FOIL the last one. But if they asked me to do this, there's no way I'm going to be able to FOIL it.
You don't have to be trig.
Yeah, we got to change it to trig form. Right? For small exponents, if you have to change it, it doesn't save you as much time. But for big exponents, yeah, it saves a lot of time. It's kind of like using your car to drive across the parking lot. Right? It doesn't save you much time, if it's a small parking lot. But if you have to drive a far distance, then going in a car is going to save you a lot of time. Okay, so how do we get the radius of that? Use the Pythagorean Theorem. So what's 1 squared?
1.
Square root of 3 squared?
3.
And 1 plus 3?
4.
And take the square root.
2.
So there's your radius.
Is
So
the
we got that.
I under that square root?
No. Nope. And now what quadrant is that point in?
Positive.
Yep. Quadrant 1. What's the formula for an angle in quadrant 1?
0 y over
Inverse
inverse.
of y. So it's really just the inverse tangent of square root of 3. Okay, so let's see what our angle is. Second, inverse tangent, square root of 3, gives me a 60-degree angle. Okay, so now I can write that in trig form. R cosine 60 plus what?
Sine 60.
That's part of it.
I sine 60.
I sine 60. And we're taking all of that and cubing it. So when you cube that, what's your radius going to be?
4. Wait. 8.
8. Raise the radius to the power. So 2 cubed. And what about your angle? Multiply your angle times the power. Cosine 1/8. That's it. So no foiling, no odd squareds, none.
That's nice to meet.
So that's what you wrote right here is the trig form of the answer. Okay, that's trig form. Now, I told you we're not going to do this a lot today, but we'll do it for a couple of them. What if I wanted standard form? What do I have to do? Yeah, multiply it out. 8 cosine 180. That's negative 8. Plus 8 sine 180, and then put an I next to it. 8 sine 180 is 0. So what's 0i times 8? Just 0. So that's the answer in standard form.
What was cosine 180 again? 1.
Cosine of 180 was 1. Yep. Negative 1. It's 8 times negative 1. Okay. So now to kind of make a connection between this and what we're going to get to next. We cubed that, and we got that. How could you undo this and get that back? Take the cube root. So if you take the cube root of negative 8, you might be thinking, well, isn't the answer negative 2? Is negative 2 times negative 2 times negative 2 negative 8? Yes, that's one of the answers. But another answer, if you take the cube root of negative 8, is 1 plus root 3i. So we're going to learn that whenever you take a root, there's as many roots as the root you're trying to find. Cube root has 3 answers. Square roots always have 2. I think the highest one we're going to do is a 5th root, and it has 5 answers. But any question on that idea, how we cubed that, and we got negative 8. So if you cube root negative 8, you'd get back to what you started.
So the standard form is 8 times 1 I sine. Oh, sine. What's sine 180? 0.
Yes. Yep. All right.
Will we need to ever go from standard form back to form up top?
Well, that's what you did right here. You went from standard form. We had to get it into trig form to start the problem.
Oh.
So this was standard form to trig form. And then when I was done, I changed my answer from trig form back to standard. So we did both.
But should we go back to being the way it was?
Well, they're the same.
What's that?
They're both standard form, aren't they?
Yeah, so this is your original number, and then this was the answer to that number cubed.
Oh.
So these aren't the same thing. This number is that number cubed.
But they're both in standard form.
But they're both in standard form.
Okay.
Yeah.
Now this one would take a while. If you had to raise it to the 8th power, you'd be foiling that times itself 8 times. So it's going to be way faster to just find these two things. Okay. What quadrant is that in? Left and up. What's your formula for theta in that quadrant?
It is pi plus inverse tangent of x.
Yeah, I'm just going to do 180. But you could do pi if you're in radians. Now, inverse tangent of, that's y, that's x. What's y divided by x?
-1.
Negative 1. They're the same, except one's positive, one's negative. Inverse tangent of negative 1, if you type that in, you're going to get negative 45. What's negative 180 plus negative 45?
270.
180 minus
135.
135. All right, so there's your angle. Now your radius, we're going to use Pythagorean Theorem. And I think we did one like this in the homework. What do you get when you square root 2 over 2? Yeah, I know we did this. We did in the homework.
2. 1.
1/2.
Negative 1.
2, no, positive, because you square it, the negative's gone.
Oh.
So 2/4 plus, what do you get here? 2/4 again. 2/4 plus 2/4 is 4/4, which is 1. And what's the square root of 1? 1. So there's your radius. Okay, that's the hard part. So now we've got it in trig form. Since it's a 1, we don't even really need it, but let's just put it. Cosine 135, I sine 135. And what power are we raising it to? 8th. Okay. What's going to be my radius when I raise that to the 8th power?
1.
Still 1. Starts 1, it's always 1. And what's the calculation for my angle? 8 times 135. So that's going to be 1080. Now, we'll start. 1080. But I would not have an answer like that as a multiple choice answer on a test. Why?
Because you can simplify, or you can make it within 0.
Yeah, you always want your angle between 0 and 360. So how do you do that? Subtract 360. That gives you 720. And then you could actually subtract 2 more times. So what's 1080 the same as? 0 degrees. So it's 1 cosine 0, I sine 0. That's the trig form of the answer. If you wanted it in standard form, just do it out. The 1 doesn't even matter. You don't even have to distribute it. What's the cosine of 0?
0.
So remember, cosine looks like this.
1.
1. So that's 1. What's the sine of 0? That's 0. I times 0 is what?
0.
It's gone. So all you have is this, which is 1. So if you raise that number to the 8th power, the answer that you get is 1.
Wow. Really?
And it looks like it's kind of messy because it's the root 2 over 2, but that actually is a very nice angle. It's a 45-degree angle. That's why it comes out so nice. If you change this to like a root 2 over 7, you just pick a random number, then it's not going to come out nice. All right. So I already asked you this. In example 1, we cubed a number. What's the opposite of that?
Square root. Cube root.
Cube root. Yeah. So if you take the answer that we got was -8, and you cube root it, you could go back to the original problem. So you cubed that to get that. So you could cube root that to go back to that. Okay? And that's what we want to take a look at how to do now. Okay, taking a cube root, or a 4th root, or a 5th root. Anything up to 5. There's no reason you couldn't go up to 20. It's just it's going to take a while to get all the answers.
Thank you.
All right, so let's take a look. First of all, if you want to find a root, and say somebody didn't understand what it meant to find a root, but they understood algebra. They just don't understand what like a square root means. If you wanted to find the square root of 16, this is the equation you could set up and tell somebody, if you can solve that equation and get the answer, then you'll know what is called the square root of 16. You have to find a number that when you square it, you get 16. Does that make sense? If you solve that, you're solving for the square root of 16? Okay. So the idea in general is if you want to find the nth root of a, not just the square root of 16 or the cube root of 10, but if you want to find the nth root of a, you put the root that you want to find there, and you put what you want to find the root of on the other side. So they have to tell you this in a problem, and they have to tell you this in the problem. What they're not going to tell you is that. You have to find that. In this case, it would be 4. That's the answer to the square root of 16. So you're setting up an equation just like that every time. That's your first step. Now, one special thing that you might see, this is kind of like off to the side, but if you ever see in the book the directions, find the square root of unity. Unity is just a fancy way of saying 1. I usually just, I say 1. But if you see that direction, now you know what it means. Find the third root of unity, find the cube roots of 1. Okay. So, first step, set up that equation.
What would you know all these formulas from test tomorrow?
You can have an index card. So, you guys just basically wrote that down. You've got to set that equation up, filling in what they tell you for n and a. So, if I skip to a problem just to show you, find the cube roots of -1. Cube means 3, and you're finding the roots of -1. 3, -1. 3, -1 would go in the 2 spots I just circled. That would be your first step. We're not going to have any numbers as we go through the steps, so it might look a little more confusing. Remember, we're dealing with complex numbers now. So the answers that you find and that number that I give you could be imaginary. They're not always going to be imaginary, but they could be. Okay, so they could be elements of the complex number system. Now, if I give you a problem, let's go back to that one we were looking at. Cube roots of -1. Is that number in trig form?
No.
No.
It's not. It's in,
Yeah, it's basically like this if you want to think about it. It's -1 plus 0i. That's not trig form. So step 1 is to change it to trig form. So, first thing you're going to have to do is figure out r and theta. When I put the little subscript, that means it's something that you actually have to find right away. You use Pythagorean Theorem to find r1, and you use inverse tangent of y over x to get theta 1, just like we've been doing. Okay, the next thing is you're going to fill that in for z. Fill in exactly like that. This is what you're solving for. You're trying to solve for the r, and you're trying to solve for the theta, for whatever root you're taking. So when you fill this stuff in for z, you're not going to fill in anything for the thetas and r's here. You are filling in for the theta 1s and the r 1s up above. Okay, you have to find those right away. So I'm going to write what that would look like now. Take this equation, put all of that stuff for a, and put all of the stuff below it for z. So that equation is going to look a lot bigger now. Right? It's going to look like that. Let me highlight in an actual problem what you're going to have numbers for. You're going to have a real number. You're going to have a number. You're going to have a real number right there. You're going to have a number right there. You're going to have a number right there. You're also going to have a number right there. Everything highlighted in yellow is going to be a number. Only variables are going to be on the left. And it's going to look just like that. Now, the right-hand side of this problem stays exactly the same for the rest of the problem. It doesn't change at all. But the left-hand side, we can do that out. How would you raise this number? Technically, I should write it like this. Oh. It'd be nice to not use highlighting. Let's go like this. There we go. how would you raise that number to the nth power?
You
R to the power of n.
Yeah, r to the power of n.
Parentheses n cosine, well, cosine n theta plus I sine theta.
Yep. So that's the part I said when we do roots, DeMoivre's theorem is going to tie in. That's where it just tied in.
What's the purpose of A equals R1 cosine theta?
That's going to be a value that you have to find right as your first step. That's a rate you're going to use Pythagorean theorem and inverse tangent.
Alright.
Okay. So now you have two things. Something on the left, something on the right. They have to equal each other. Well, there's a radius on the left. There's a radius on the right. Those two have to equal each other. So that's your first equation that you set up, and that's going to tell you the answer to your radius. And there is only one answer. So now when you find like the cube root or whatever, that's the radius for your cube root. Now you have that part of it. But to write a number in trig form, you need the radius and the what?
Radius and theta too?
You need the angle.
Yeah.
Now, I said to you, like, if you were taking a cube root, how many answers are there? 3. What about a fifth root? 5. So the angle is what's going to give you multiple answers. So take the angle on the left, set it equal to the angle on the right. Now, if you solve that, you're going to get one answer for the angle. Think about in trig, what did we add when we were like graphing and I said find all solutions? You put a plus something on the end, and that represented all solutions. What did we put on the end?
oh
Plus.
180. Wasn't one of those.
plus
2 pi, 2 pi n.
Yeah.
We always added 2 pi n, and that represented every answer. It's the same idea here. Or k, whatever letter you want to use. But we put plus 2 pi k, and that gives us all the answers. Now, I'll do the first problem with you guys in radians. After that, I'm going to do degrees because it just makes the numbers easier. And that is basically your format. This tells you how to get the radius for your answer. This tells you how to get the angle. And that will have multiple answers. It's going to have multiple answers because of that right there. You've got a variable right there. This won't be a variable. Remember I highlighted theta 1 in yellow? That's going to be an actual number, like 10 degrees when we do a problem. So, when you find roots, you're only going to get a single answer for r. One answer. Single answer. But you're going to get as many answers for theta as the root you're taking. Highest one you're going to do today is a fifth root. And it will have 5 answers.
We have to do 5 more steps.
You have to use this, what's in the box on the right. That gives you the 5 answers.
Alright.
So the way that box on the right gives you the 5 answers, okay, I already told you guys that, is you have to plug in 5 numbers for k. You want 4 answers, you plug in 4 numbers for k. 2 answers, 2. You can't just pick any random numbers. You start at 0, and you plug in up to n minus 1. So what do I mean? If you were finding a cube root, the numbers you would plug in for k are 0, 1, 2. That's how you'd get 3 answers. If you were doing a fifth root, you would plug in 0, 1, 2, 3, 4. And that's how you'd get your 5 answers, because you're starting at 0. Probably like a fourth root.
Okay.
So you have to plug in 0, 1, 2, 3. So it means you're going to have to do 4 calculations at the end. All right, so it's a lot of steps. So we'll try a problem now.
Yeah.
Okay, and this is all we're doing for the rest of the class, just finding roots. So we'll do as many as we can. We did 2 in the last class, but I think we'll get to at least 3, maybe 4. But they were 25 minutes behind you guys. Okay, so find the 4th roots of unity. Okay, find the 4th roots of 1. That means solve that equation. Like if you said to me, find the square roots of 16, I would say, okay, something squared gives me 16. If I can figure that out, then I know the square root of 16. Same idea. Find the 4th roots of 1. Okay. Now, this 1 has an imaginary part, but it's not written. What is it? Yeah, so if you want to put that, you can. It's not really important. But what is important is that we write this side and this side in trig form. Now, let's start with z. What did I say to fill in for z? And I wrote fill in exactly next to it.
What was the formula?
Yeah, what did I say to fill in for z? And I put right next to it.
R.
Yep.
Open parenthesis cosine theta plus r sine theta
Right.
plus minus.
And r and theta are what you're solving for. That's the goal. And all of that is to the 4th power.
We're trying to find z for 1 plus imaginary 0.
Right, so now we have to work with that. Is that trig form?
That's standard.
No.
That's standard. You got to have it in trig form to make this work. So how would you graph 1 plus 0i?
It would be
Right on
one
the
of the
axis.
yeah.
That's point right there. What's the radius of that point?
1.
You don't really need Pythagorean theorem. It's just 1. And what's the angle for that point?
0.
0. Let's do it in radians. Okay? 0 degrees, 0 radians is the same. So it's 1 cosine 0, I sine 0. Okay. Now, how can you simplify the left-hand side?
R to the 4th cosine 4 theta plus I sine 4 theta.
Yep. And the right-hand side, like I said, it just stays the same the whole time. That never changes. 0, I sine 0. Okay. Now, I said that the radius on the left has to match what?
On the right.
It has to match the radius on the right.
Yeah.
The angle on the left has to match
On the right.
the angle on the right. So after a while, you might be able to do some of that in your head and just say, okay, I know it's r to the 4th. I know the radius with Pythagorean theorem is 1, so it's just r to the 4th equals 1. But we're gonna write it out.
Shouldn't be 1 to the 4th as well, or no?
No, because the radius when we solved for it was just 1, not 1 to the 4th. Okay, so r to the 4th equals 1. And how would you solve that equation?
Cube root of 1, right?
Well,
cube
fourth.
of 4.
Fourth
root of 1. That's the terminology there.
And what's the 4th root of 1?
1.
1. So when you write all 4 of your answers, they all have a radius of 1. But they're going to have different angles. So the radius is always the same in every answer. It's the angle that's different. So what was our angle on the left?
4.
What's the angle on the right?
Theta 0.
Now, if you just solve that equation for theta, you're only going to find one answer. It wouldn't be wrong, but you'd be missing the others. Okay, but that answer would still be right. What do you put here to make sure you get all of them?
RK.
No, pi.
2 pi k. And now solve this for theta and get theta by itself. So how would you get rid of that 4? Yep.
Just 0.
So that's gone. So theta equals, what's 0 divided by 4?
0.
So I'm not even going to write that. And then 2/4 is 1/2 pi k. There is your formula to find your angle. So you got your radius. Here's how you find your angle. Now k is going to equal what numbers? We want to get 4 answers.
0, 1, 3.
1, 2, 3. Okay. So now we're going to write the 4 answers. And that's it. Okay. So k equals 0. K equals 1, 2, 3. What's my radius?
How can k equal 0, 1, 2, 3?
Because you start at 0 and you go up to 1 less than the root you're looking for. That's the algorithm to get the angles. So what's your radius for all of them? 1. So let's 1 cosine theta plus I sine theta. I'm going to copy that 4 times. Might have been faster, right? 1, 2, 3, and 4. Now, we're going to fill our angle in for each one of them. Start with 0. What's 0 times half pi? Or if you want to think of it as, just multiply this out.
0.
It's really pi over 2. So it's 0. Next one is when you let k equal 1. What's pi over 2 times 1? Pi over 2. And that is your second answer. What's pi over 2 times 2? Pi. And that's your third answer. What's pi over 2 times 3? 3 pi over 2. And are those trig form or standard?
Trig.
They're all trig. How would you get it in standard if that's what they wanted?
1.
Yeah. 1 times cosine, that would be your real. And 1 times sine would give you your imaginary because the I is next to sine. Those are the answers in trig form.
There's so many steps.
Yeah, that's why I did say it was the toughest part for this week.
So what does this do?
So it allows you to find roots. Like before, if I asked you to find the cube root of, say, 64, you probably could have done it and said, oh, the answer's 4.
Okay.
But there's 2 other cube roots that you didn't know about that are imaginary. So now you can find all the cube roots of 64.
We can find the real ones and
The imaginary ones. Yep. Real and imaginary. Yep. All right, let's try. We'll try another one. I'm not going to graph it, but let's switch it up. Let's do this one.
Oh boy.
And we can go back to one of the other ones. Okay. I want to find the 5th roots of this number. So what's the first thing I have to do in that equation?
Find R.
Right, so let's find the r and the theta. If you were going to write 1 plus I in trig form, what's the r?
R.
1 squared is 0 squared.
Well, no, there's a 1 in front of that too.
So 1 squared is 2.
Mm-hmm.
And then square root of 2.
Square root of 2
Oh,
is
it's squared.
just square root of 2. So your radius is square root of 2. What's your angle?
It's going to be, if that's in the first quadrant, then it's going to be inverse tangent of 1 over
Mhm.
b.
It's the inverse tangent of 1, which is how much?
45.
45, right?
Yeah.
because you went over 1, up 1. So you got an isosceles triangle right there. Any question on why it's 45?
There's a 90-degree angle too.
Oh, yeah.
45.
Okay. So now, on the right-hand side, what would you put?
R open parentheses cosine theta plus I sine theta.
Yep.
And
So far, you haven't done anything yet that we didn't do last night. All you did was change that to trig form. Now the left-hand side is stuff I taught you today. What do you always replace z with?
R thing. R cosine theta. Yeah, and then sine theta. It's theta, right?
Yes.
Theta.
Now, what power are we raising that to?
5.
The 5. So let's do it at the same time so we don't have to write it twice. How would this look if you raise it to the 5th power?
R to the 5th, 5 cosine 5 theta, 5 sine 5.
Yep. And now we're at the last step, which is just to make our two equations to find r and find theta.
So now we need to find R, which is R to the 5th plus the cube root of theta.
Equals the what? Yep. Square root of 2. Now, you'll see why I'm going to do this in a second. What's another way to say square root of 2 if you wanted to use an exponent?
cosine 4.
2 to the negative 1. 2 to the power.
2 to the, you're close.
2 to the power of 1 half.
Yes. Raising something to the 1/2 power is the same as the square root.
Oh.
And the reason why I'm doing that, now you're going to see right here. I want to get this 5 to be a 1. Because when I'm done, I want this. R equals, not r to the 5th. So you could take the 5th root of both sides. But taking a 5th root is the same as raising to what power? 1/5. And when you have a power to a power, what do you do with your exponents?
You add them. Or no.
You multiply them. What's 5 times 1/5?
5. With what? Not 1.
1. So now you have r to the 1st. And what's 2 to the 1/2 to the 1/5? 2 to the 1/10. So when you take the 5th root of a square root, that's a 10th root. It's like if you took a square root of a square root, that's a 4th root. Okay? And I just wanted to show you why with the fraction. So it's 2 to the 1/10, which you could say is the what root of 2? Yes. Doesn't matter which way you say it. Those are the same thing. Yeah, we talked a little bit about fractional exponents when we did logs. Yep. All right, so there's our radius. That's your radius in every single answer that you write. How many answers is this going to have?
10.
No, what root are we?
Oh, 5.
We're doing 5 power, so it's going to have 5
You
answers.
better not.
That'd be a lot, man. 5.
I read right now.
What's our formula? What do we write down to find the angle?
Square root of 2 to the 5th.
So the r to the 5th and the square root of 2, those are done.
Oh.
That's our radius part.
Then
So-
cosine 5. 45?
Well, first off,
Uh,
R to the 5th,
5 theta.
So the angle on the left
Oh.
equals
45. Angle on the right.
angle on the right. Now, if you only get that, you're going to get one answer. It'll be right, but you're missing the other ones. So what do you add here? Keep in mind you're in degrees.
0.
Pi k.
Oh, what?
Well, 2 pi k
2 pi
would
k.
be for radians.
Plus 360 pi.
3.
No, 360 pi.
360k. By adding 360k,
That's a lot of fun.
that finds all your
So
answers.
2 pi is equal to 360.
2 pi is equal to 360.
5 million.
Now, what do you do to get theta alone?
Divide by 5 on both sides. And now we've got theta equals 9.
Yep.
Plus. Brian, you got it. 360.
100. No, 18. Wait, no.
360 divided by 5.
72. 72k.
72. Yeah.
72.
I got there.
Good job.
So there's your formula to find your angles. And what are you going to let k equal?
0, 1, 2, 3, 4.
0, 1, 2, 3, 4. There's your 5 answers.
There's so many steps.
Yeah, it takes a little while to get used to. So let's write down our 5 answers. It's very repetitive.
5 steps. 5 answers, but it only goes up to 4.
Yep, because you're starting at 0.
Right.
So what's your radius for?
You did 1, 2, 3, 4, 5.
Thank you. You know what I should do? I should just go like this.
Just get rid of the.
Yeah. And you get rid of that left.
Okay.
And that random dot in the middle too. There we go.
What's your radius for each one?
That are 10th root of 2.
10th root.
Oh,
Just gonna move it. 10th root of 2. Cosine. Leave a little space.
Sine.
Leave some space. That's how every answer is gonna look.
Get the copy and paste on that.
Yeah. Just gonna copy and paste that. So that's our second.
What are you doing for the 1, 2?
got a couple more.
Third one. Oh yeah, I need one more up there too.
You're gonna have us do k to the 4 answers on this?
Maybe up to 4. Yeah, probably not 5. This is 5.
You know what's it? One more?
Yeah, it's just one
It's
more.
not even that painful.
Once you've gone this far, it doesn't really matter.
Yeah.
So k equals 0. What's 72 times 0?
0.
Plus 9?
9.
There's your first thing. 72 times 1?
72.
Plus 9?
81.
1, 81. 72 times 2?
216.
144.
Wait, did you say 2 or 140?
Plus 9.
Oh, I thought you said 156.
We're just yelling at numbers.
The next one's 216 plus 9, then it's
So 72 times 2 is 144.
225.
Plus 9 is 153. 72.
225.
Zach, just use it.
225.
Yep.
225.
72 times 3 plus 9 is 225.
He's recording, Zach?
No, he's not.
Yes, he is.
No, he isn't.
Prove to him you're recording.
I am.
But you already have with the other class,
And-
so it's fine.
What's 72 times?
Please use the calculator.
Is it 280 something?
280.
72 times 4 plus 9? 297.
Yeah, that.
That is all 5 answers.
Right, because if you did it again, what you'd be doing is you'd be adding another 72 and you'd get that. But what could you subtract from that?
360.
And it would make it what?
9.
9.
Oh my
So now you're doing the first answer again.
69. 9.
So those are the five answers. All right, so we'll try one more. We're gonna do cube root. I'm gonna go back down to just 3 answers.
I like that.
So let's try. You want to do the cube? Let's do the cube roots of -8.
Negatives.
Now, before we start, can anyone just tell me right off the top of their head what's one of the cube roots of -8?
-2.
-2. So let's just put that off to the side.
No, I don't.
Remember, our answers are going to be in trig form, but one of them will come out to -2 if you convert it. So let's go through them and see what happens. Okay, so what's the equation you're setting up? I'll give you a hint. It looks something like that.
Z to the 3
Yep.
equals -8 plus
Good.
0i
Yep, you can put the plus 0i if you want.
plus boy.
All right. Now, what's your next step?
R cosine theta plus I sine theta.
R cosine theta plus I sine theta. And what power are you raising it
To
to?
the 3.
So let's do it right now.
So
R to the 3rd. Cosine theta, sine theta.
Yep. Now what do you do?
Equals, well, we gotta find what r is. So r to the third is equal to
So how do you graph that?
-8 that
Negative
way, and then
8.
on the x.
So it's like right there.
The
so
radius
negative 8 is 0.
The radius is 8.
What's negative 8 squared?
So what's your radius first?
So it is 8.
8. Yep. 8 cosine. Now you don't have to worry about using inverse trig because it's on the axis.
Pi, right?
It's pi, but let's do 180.
Okay.
How is the radius just 8 again?
Because if you measure, it's 1, 2, 3, 4,
Those are the
5,
absolute
6, 7,
value.
8. Yep. I sine 180. Okay. So what's going to be the equation for your radius?
R cubed equals 80.
Perfect. And what's r there? 2. So you're going to have how many answers to this problem? 3. And they're all going to have a radius of
2. We're making progress.
Okay. What's your equation for the angle?
That's gonna be 2. No.
What's the angle on the left?
3 theta. 3 theta
Equals
equals 180 plus 2 pi k. So plus 180 k.
Plus how much? 360. It's either 2 pi or 360. If you see the degree symbol, put 360. Now, how do you get theta by itself?
Divide by 3.
Divide 3, divide 3, divide 3. 60 plus 120k. So there's your formula for your angles. What's k going to equal?
0, 1, 2.
0, 1, 2. All right, so let's write our answers.
0, k1, k2.
Radius on all of them?
2.
2. Cosine, cosine, cosine. Plus. I sine.
Did you hang it tired after the inverse?
Yes. It does. So now, first angle. What are you plugging in for k?
0.
0 times 120
0.
plus 60.
60.
60. That's 1. Second answer. 120 times 1
120.
plus 60. 180. 180.
That's the last one.
120 times 2
Exactly.
240.
plus 60.
300.
300.
Yeah.
And those are all your answers. Now, at the very beginning, you guys told me one of these answers was what?
Negative 2.
Negative 2. Watch what happens if you do that one out. 2 cosine 180 gives you negative 2 plus I. Now we got to do 2 sine 180. 2 sine 180. 0. What's I times 0?
0.
What are you left with?
Whoa.
Negative 2.
Are the other two?
Which is
errors?
exactly the answer that you got.
Are the other two errors if you reported?
Nope, the other two are going to be imaginary.
I'm starting to get it. It's just extremely tedious.
There's just so much. It's so long.
This one and this one will be imaginary. And notice how many imaginary answers are there?
2.
2. They always come in pairs.
Oh.
You never will have, and we mentioned that for something else. Imaginaries, you'll never have one of them. You'll always have 2.
You get 3 of them?
Because if it's
No, there has to be an even amount. They come in pairs.
So if you have k to the 4th power.
So fourth power, you're going to have 2 real, 2 imaginary.
And so for the 5th power, you're going to have 3 real, 2 imaginary, or 4 imaginary.
Yeah, they're always going to come in pairs. So it
could be 4 imaginary, 1 real, or
depending on the problem, yeah.
3 imaginary, 2 real.
4.
Think of like if I said to you, what's the 4th root of 1?
Or 1.
Negative 1 or 1. So those are your 2 real answers. The 2 other ones are imaginary. So the way you'd find them is to do this. And 2 of them would come out very nice, just like this one came out to negative. All right. Questions on that? Now, I want to go back to this one and show you one thing that just all you have to do is watch this. How many answers did we just get there?
5.
We got 5. What shape has
And
4 sides?
Square.
It's square. How about 5 sides?
Pentagon.
Pentagon has 5 sides because pent rhymes with tent, and a tent has 5 sides.
That's really stupid.
That's what I was taught in middle school.
So this might
That doesn't even all
not
have
be
sides.
ish.
We need to fix that.
All tents have 5 sides, but not all 5 sides.
It's a little off, but you get the idea. So
That's just not true.
a pentagon's not there.
It makes
So,
a circle look uneven.
We just found
We made a pentagram.
5 sides, right? 5 answers.
You can't see it, but the big pentagon. Oh, they can see
1, 2, 3, 4, 5. If you were to draw those 5 answers, that's how they would look. They would be on a circle, and they would all be equally spaced, and they would make a pentagon.
Nice and useful. For all the time that might need 5 dots on a circle.
So if you were going to find 4 answers, if your problem had 4 answers, it would give you the corners of a square on a circle. If your problem had 3 answers, it would be like an equilateral triangle. So there is a pattern to the answers. They're all equally spaced on a circle.
Would you be using this to kind of like find shapes through finding their contact points on the circle? You could find a triangle, you could find a square, you could find a pentagon.
Yeah, you really
a rectangle.
you could find anything. You could find the coordinates of those points. Yep, exactly.
Give me that.
All right.
You guys can't see, but Mr. Babb just entered the room.
So that's your that's your homework for tonight. Don't forget, I'll be after school today if you need any extra help. Does anybody have a test they need to make up from last
Mr.
week?
Babb just left.
Yes, he did. What else?
Can you
So-
put the belt sound?
Don't forget, progress reports close tomorrow. So whatever you don't have made up or turned in, I'm giving you progress report, whatever I gotta give you. Awesome.
So can you play the bell sound?